In 7.1, we have a bunch of different topics to kind of go through, and they're somewhat interrelated and then others that are not. Anyway, so we're going to start with, so this is solving differential equations and verifying solutions, and also exponential growth and decay. We've kind of done this. I know we've done this in Algebra 2. We're going to look at it a little bit differently today, but this should seem pretty familiar to you. All right, so solving differential equations. First off, they are equations with derivatives in them. That's what makes it a differential equation. So we're going to start off on page 155, so you can go there. I'm going to give you a bunch of sort of steps to follow, and in most cases, you're going to want to follow them exactly. Right. For starters, we're going to be solving equations where the variables will be able to be separated. There are other types of differential equations that we aren't going to look at. And, in college, if you take a differential equations class, you'll get into some of that stuff. But the ones that we're going to look at are ones where we can separate the variables. So first of all, if the problem is written with a y prime instead of a dy dx, you're going to want to change that, because what we're going to do is separate the dy and the dx. And then so multiply both sides by dx. So we're going to have the dx on one side, the dy on one side, with the idea that we're going to get the y's on one side and integrate, the x's on one side and integrate. So then you got to separate the variables, and as he states, it's the most crucial step, because again, we're trying to get the y's on one side with the dy, the x's on one side with the dx. Once we've done that, you're going to integrate, and you're going to have to add c's in there. Now, in some cases, you're going to put one c. Some cases, you're going to put a c sub 1, and then later on in the problem, you'll have a c sub 2. And sometimes you don't even figure that out until you're partway through the problem. And so maybe you start off with just a c without a subscript, and then you change it. You realize, oh, I'm going to have another c along the way, so I better add a subscript there. Then we're going to solve for y, because of course our goal is to solve these. And then, if an initial condition is given to find c, then we'll find c and then have a general equation that doesn't have a c and it has the actual number in it. So that's the process that we're going to follow. We'll go through a couple examples, and it shouldn't be too bad. So we'll start with example 1. Looks pretty simple. So notice here, I already went ahead and changed y prime to dy dx. So I'm gonna separate. I'm gonna get the x's on one side, the y's on the other, and just by sliding that x over, and then multiplying both sides by dx, which make it go away here and make it pop up on the other side. And so from here, what you've got to do is just integrate both sides. This is a pretty simple integration. And I just want to talk about the c a little bit after we do that integration. So here's what that's going to look like. So we're going to integrate both sides. Of course, this is y squared, and I could have a plus c on this side, and this is negative x squared over 2, or I could have a c on this side. So the trick is you usually don't put it on both sides, because a constant on one side and a constant on the other side, you could move them all together to be one constant. So depending on the problem, you might want to put the c on this side, you might want to put the c on this side. Since we're usually trying to get y by itself, you put the c on the other side from y. That's the sort of general strategy, and maybe write that down, because you put the c away from the y if you're trying to get the y by itself. That's just sort of the general strategy that we'll use there, okay? Now, we're not asked to find y squared, we're asked to find y. And so in order to do that in this problem, we've got to take the square root of both sides, which means we have to take the plus or minus the square root. And so here's the trick to problems like these. There are not two solutions. It's an or situation. Either y is the positive square root of this, or it is the negative square root of this. It's not both. And usually there'll be some other conditions in the problem that will tell us whether or not y is increasing or y is decreasing, or y is positive, or y is negative. In this problem, it's super basic. We're just really getting a quick start to these types of problems. So it's not necessary to single one of them out. It's okay to say it's this or this. But normally when we solve a square root type situation, we say it's both. It's the positive or the negative. In these types of questions, in differential equation types of questions, it's going to be one or the other, not both. All right, let's move on to example. Okay, so we've got this differential equation, and again, as you're going through this, pause as you need to take time for yourself to screenshot and add in, and or rewind for that matter if you miss something. All right, so we've got example 3: y minus 2 equals x times dy dx if y equals when y equals 1/2 when x equals 1. And so we want to put our answer in form of y equals f of x, so we're going to get y by itself again. So here's how we're going to start. I'm going to start separating the dy and the dx again. All right, so I multiplied both sides by dx. So we've got x dy and y minus 2 times dx, which is flipped, right? We need this dx to be with the x and this dy to be with the y, which means I'm going to divide this side by y minus 2, and I'm going to divide this side by x. So that's going to get me 1 over x dx equals 1 over y minus 2 dy. And then, of course, we're going to integrate. And by now we understand that when you integrate 1 over something, we're talking about natural log. And we're going to start off with absolute value, and then eventually it's going to go away. Okay, so I've got the natural log of x, absolute value of x, plus c1, okay, because there's going to be another c involved. And this kind of is the giveaway. We have an initial c, and because I'm going to be able to find more, well, that's not true. This is not the giveaway. There's something else that's going to happen. It's because of the natural logs. But when I did this problem for the first time, I just had a c here, and when I realized what was going on over here, I went back and changed it. And what I would suggest is if you want to start like that with a c, and then after you get through the problem, you realize you're going to have another c, that's when you can add the subscript in and kind of backtrack a little bit. Anyway, notice I put the c on the x side away from the y. Same idea. Now we've got to get rid of these natural logs. And the way that we do that is we just make them the power. So e to this power, e to that power, and it's going to look like this. This is pretty simple. We got a little bit of algebra that we have to deal with here. Remember that when we multiply exponents with the same base, we add the powers. So if I decompose that, I can think of this as e to the natural log of x times e to the c, c1. So again, this is just my algebra. See, and if you look at this here, if I wanted to go from here to here, I add the powers. So you can deconstruct that going the opposite direction. So I have e to the natural, and hopefully you can tell why I wanted to do that. E to the natural log of x, the e and the natural log are going to cancel. E to the natural log of y minus 2, the e's are going to cancel. The e and the natural log are going to cancel. And this is where I get my second constant. Remember, e is just a special irrational number. So this is a number to another power, that's a number. So this all is where my second constant comes from, okay? So here's where I'm at. This is where my second constant comes from. So these cancel, I get x. These cancel, I get y minus 2. Now I can use my information here to come up with my second constant. And so I'm going to do that. I'm just going to plug that in. 1 for x, 1/2 for y, and solve for c sub 2. This is negative 3/2, so that's my c sub 2. And then from there, I just plug it in. And so that's going to go here, and then I'm going to get the y by itself. I got to move the 2 over, right? So I get y equals this plus 2. Well, this is negative 3/2 times x. Then I can just move my 2 over, and we are done. I'm still thinking about the question about why do the absolute values symbols just drop out. And I believe it has to do with the overarching increasing and or decreasing value of y. And I will spend some time thinking about that and come back with a better answer than that. But for now, just know that typically speaking, it's going to drop out. I don't think it's that important to understand why at this point. But I won't leave you hanging. I'll come up with something. That's the first part, solving differential equations. We'll move on to the verifying, and this is pretty small piece of this, verifying solutions. Basically just confirming that something is a solution, right? And we do this, here's example 5 we're going to look at. We're trying to decide, is y equals 1/2 e to the x plus e to the negative x a solution to this equation? And so what I want you to be thinking about here, think about how we did this in algebra. If we wanted to verify that 4 was a solution to the said equation, we plug 4 in. Everywhere there was an x, did the left-hand side equal the right-hand side? If it did, then it checked out. If it didn't, then we knew that that wasn't a solution. So we're going to do the same thing here. The problem is I have y, they give us y. I don't have y prime. And so once I find y prime, or I take the derivative of this, I'm going to just replace everything. E to the x is going to stay e to the x. And I'm going to see if I can make the left-hand side and the right-hand side equal to each other. If they are, then they're solutions. Then this is a solution. If they are not, then it's not. Okay. So let's start with y prime. All right. This 1/2 e to the x, because the derivative of e to the x is e to the x. Chain rule, I got to multiply by -1. So here's my y prime. So now I'm going to substitute in red for red, blue for blue. And then see if the left-hand side equals the right-hand side. What's important too here, I see this happen, but to me it's not right. You don't move from side to side during a check, right? When I plug in here, I'm trying to make this, see if it equals this. I'm not moving from side to side here. I'm just going to, obviously my goal is to simplify this down. If this simplifies down and equals this, then we're good. So I have to distribute this negative, right? So I get e to the x minus 1/2 e to the x minus e to the negative x. Well, this is 1 e to the x minus 1/2 e to the x, just 1/2 e to the x. Bam, we're good. Left-hand side equals the right-hand side. That's as simple as the verifying solutions part is. The last part of this section is exponential growth and decay. And in Algebra 2, you saw an equation that looks very similar to what I'm about to show you. And maybe in some of your science classes, you've seen something like this as well. And so we're going to work through that a little bit. There's formula, and then I'm going to explain what the meanings of the formulas are. Okay, so this is the basic law, they call it basic law of exponential growth and decay. Y equals C, some constant, e to the kt. And what all these variables mean, okay, C is the initial value, okay, the starting amount at time 0. K is this special constant. And it's either the growth constant or the decay constant. If it's negative, it's decay. If it's positive, it's growth. And oftentimes in these problems, you will have to find K, or they have to give you K. And for whatever the scenario is that they're talking about, K remains the same for all problems within that particular scenario. The time will change, the ending amount will change, the starting amount will change, that kind of thing. And then our variables, t is time, y is the amount of substance after that amount of time. So after time, whatever the units are, passes, y will be the amount left. So the ending amount, starting amount, e is e, our growth or decay constant, and then the amount of time. So we'll look at example 8. Let y represent the mass in pounds of radioactive element whose half-life is 4,000 years. If there are 200 pounds of the element in an inactive mine, how much will remain in 1,000 years, express your answer in 3 or more decimal places, okay? We're going to do 3, and I'm going to just cross out the or more. Let's get rid of that. It's just 3. We want everything to be 3. Now, notice here they don't talk about a growth or a decay constant. So no K. They have not given us K. We have to find K. Let's understand what the meaning of half-life is, okay? Half-life is the amount of time it takes for some substance to lose half of its amount, right? So it decomposes. So if you started off with 50 grams of something, how long would it take to get to 25 grams? If we started with 10,000 pounds, how long would it take to get to 5,000 pounds? That's what the half-life means, how long it takes for half of it to go away. And what they're telling us is that this element, it takes 4,000 years for half of it to go away. That is enough information for us to figure out what in this case, decay constant will be. And so here's our setup to find K first, all right? So it's not given, so we have to find K. So we start with this equation, all right? And if C is my initial amount, the half-life will be what's left of that over some period of time, and half of this. So in order to find K, we just start like this. We take our initial amount, whatever it is, doesn't even matter, and I multiply it by half, and this will be half of it. And what they're telling us is that it takes 4,000 years for half of whatever our starting amount to go away. And this is enough information to be able to find K. In this half-life piece where it's half of the starting amount, this will always kind of be the same, and then you just need the time. So if you know how long it takes to lose half of it, then you can solve for K pretty easily. Now, the nice thing about this is when I have a C on both sides, they just cancel out. We don't even have to worry about them anymore. Well, now I got to figure out how to get this K by itself. And the way that we do that is just to take the natural log of both sides. So first the C's cancel, and I take the natural log of both sides, and this is natural log of 1/2, and then I divide by 4,000. So here's where I take the natural log of both sides. The natural log of this side, the E cancels out in that 4,000. It actually doesn't cancel out. Let me write this over here. So this natural log of 1/2 equals the natural log of E to the 4,000K. So this stays the same, and this power drops down in front. If you remember natural log and your power rules, the 4,000K drops in front, and this is just the natural log of E. Well, this is 1. So that's how we get from here to here. The natural log of E is 1. And then natural log of 1/2 divided by 4,000 is K. Here's what's important about K. Yes, you could type this into your calculator, and yes, you can get some crazy decimal. Just save that number. Do not ever round this number in order to find your final answer, okay? If you round this at all, I don't care 3 places or whatever, your final answer is not going to be as accurate as it should be. And I would be willing to bet that on the AP exam, that's going to matter, okay? So if you type this in your calculator, and then when I go through and we're going to reuse this equation, when you insert your K, you're going to want to go arrow up back to that number and hit enter so that it puts the whole thing in. And actually still it won't put the whole thing in. My suggestion is to not find the decimal of this at all unless it asks for it specifically in the problem. So I'm going to show you how to do that without. It's calculator work, but nothing that dramatic. All right, so here's what we're talking about. So if there's 200 pounds to start with, my starting amount, okay, my K, so literally I just copied and pasted and put it there, and we want to know how much is left of that 200 pounds in 1,000 years. This work you write out, the rest of it is in the calculator. And so you can type this in. I did it, and you can do this pretty easily. If you really want to do some canceling first, you can do that too, but I wouldn't advise it. I would type it in just like this, and then the calculator will do the work for you. okay? So since we're going 3 places, this ends up being 168.179 pounds, which we would not expect it to be half, right? Because it takes 4,000 years to get to 100. Half-life is 4,000. So we lost, 31 point whatever pounds in that 1,000 years. And so that seems like a reasonable estimate of what will be left.